In this video, we're going to talk about power functions, and we're going to introduce you to polynomial functions. A power function is a function in the form of p of x is equal to a times x to the n. A is your coefficient, which can be any real number. And n is your exponent, which also can be any real number. And one other thing to notice is that power functions are only one term. Some examples of power functions might be p of x is equal to 2x to the 1/4, or p of x is equal to negative 3x to the square root of 5, or p of x is equal to negative 2/5 times x to the 0.72. These are all power functions because they're one term, right? They're all one term. I have a coefficient and an exponent that are real numbers. Now, one more power function I want to show you, because we've talked about it before. P of x is equal to x squared. This is a quadratic. We've talked about it before. It's a quadratic because it's a degree 2. And notice that in this case, I have a quadratic that is also a power function. In this case, this x squared is both. Notice I have a coefficient, even though I didn't write it in there, it's 1 times x squared. My coefficient is 1, which is a real number, and my exponent is 2, which is a real number, and it's one term. So this is also a power function. Okay, now a polynomial, on the other hand, looks like this. Notice one difference right off the bat is that a polynomial can have multiple terms. It doesn't have to have multiple terms, but it can. Your a's are your coefficients. So let me highlight those in blue. These are my coefficients. Okay, those are my a's. And my a's can be any real number. Let me highlight that in blue so that you can match it up. Okay, then in green, we'll look at the exponents. Those are my n's. Okay, my n's are my exponents, but here's another difference between power functions and polynomials. Power functions, the exponents can be any real number, so that means it can be fractions and decimals and square roots, whereas the polynomial, the n's or our exponents, has to be non-negative integers. In other words, they have to be whole numbers. They have to be 0, 1, 2, 3, 4, 5, and so on. Okay, now we have the leading coefficient. The leading coefficient would be your an. So think of your leading coefficient as the coefficient that's in the front when you list it in order, in descending order from the highest or the largest exponent for x all the way down to the smallest exponent for x. So when you list it in descending order, that coefficient that's in the front, that's going to be your leading coefficient. Now the exponent that goes with that leading term is called your degree. That's going to be your largest exponent for x. So in those two things, your leading coefficient and your degree are going to be important when we discuss later the shape of the polynomial. When we go to graph it, those two things are going to help us determine the shape of the graph. Now, before we move on, I want to go through 3 examples with you to make sure that we can distinguish the difference between a power function and a polynomial. Now in this first example, 2 to the power of x minus 6, this is neither a power function nor is it a polynomial function because it doesn't fit the definition. If you go back and look at the definition of a polynomial or a power function, our x's are not in the exponent. So that's going to be a different function that we talk about later in the semester called an exponential function. But it is not a power function and it is not a polynomial function. So I'm going to list this as neither. And that is because x is in the exponent. In the second example, f of x is equal to x to the 6th. This is actually a power function and a polynomial function. This fits both definitions. If you notice, we have one term, which fits the definition of a power function, and we have coefficients and exponent that is real numbers, again, fits the definition of power function. But it also fits the definition of a polynomial function because my exponent is a non-negative integer, which is 6. So it works for both definitions. In this last example here, this is a polynomial function only. And the reason for that is if I actually go through and multiply out 2x times x plus 2 times x minus 4 squared, I'm going to have multiple terms. So right off the bat, I can knock out the fact that this is definitely not a power function because we have multiple terms. But if I then go on and look at my integers, if I were to expand all that and multiply it out, all my integers would be positive or non-negative integers. They would be all whole numbers. So this definitely fits polynomial definition.